What is uniform circular motion? First of all, let's imagine a Ferris wheel and the cabins going around it. They are going in uniform circular motion. Uniform means that something is moving at a constant speed. However, even if the cabin is moving at a constant speed, it is not moving at a constant velocity. Remember, the velocity has two components, speed and direction. Since the cabin is changing velocity, it does have some acceleration. Remember that acceleration is just the change in velocity over the change in time. The acceleration is pointed inwards to the center of this circle, while the velocity is perpendicular to this line. The good news is that the acceleration has its own equation for circular motion, which is acceleration equals to speed squared over the radius of the circle. This is called the centripetal acceleration. Let's now go and solve three different problems solving for Newton's laws using this new information.
Problem 1. In this problem, a puck is attached to the end of a cord that is 1.20 meters long. The puck moves in a horizontal circle as shown in the beautiful drawing up there. If the cord can withstand a maximum tension of 55 newtons, how fast can the puck spin? We're also given the puck's mass, that is 0.300 kilograms. So we're looking for the maximum speed. We know our two equations are centripetal acceleration equals the speed squared over radius and force equals mass times acceleration. That is just Newton's second law. So if I plug in the acceleration to the second equation, we have force equals mass times the speed squared over radius. I will draw now the free body diagram of the puck so we can see that the only force applied to the horizontal is the tension force. Gravity and normal forces balance each other out. So let's rearrange this equation to solve for speed. We just need to plug in all of our values and we get that the maximum speed then is equal to 14.83 meters per second. Problem number 2. In the Bohr's model of the hydrogen atom, an electron moves in a circular path around a proton. We're given the electron's mass, approximate speed, and the radius. What is the force acting on the electron and the centripetal acceleration? So again, we will use Newton's second law, equation F equal to ma, and the centripetal acceleration equations. We can just plug in the centripetal acceleration equation into the force one just like previously and we can solve for the force. So, force equals to the electron's mass, which is 9.11 times 10 to the negative 31st kilograms, times the speed, which is 2.20 times 10 to the 6 meters per second, all that square, over the radius, which is 0.530 times 10 to the minus 10 meters. That is equal to 8.319 times 10 to the minus 8 newtons. Then, we know that acceleration is just force over mass. You can also solve for acceleration by using the acceleration equal to speed squared over radius. You should get the same response. So the acceleration is equal to 9.13 times 10 to the 22nd meters per second square. Problem number 3. A 1200 kilogram car is moving on a horizontal road going in circles. If the radius is 50 meters and the coefficient of static friction is 0.500, how fast can the car go and make the turn? This problem is a little different. We must also calculate the static friction, but why is that? The force that enables the car to remain in a circular path is the force of static friction. If there was no static friction, like on ice for example, the car will continue on a straight line and slide off the curved road. Therefore, the maximum speed the car can have while going in a circle must be the speed at the verge of sliding, so the same as the maximum static friction. We know that maximum static friction is equal to the coefficient of static friction times normal force. So, we need to also calculate the normal force. I will draw the free body diagram to answer the force equation better. We see that vertically we have the normal force upwards and gravity force downwards. Since the car is not moving in the vertical direction, normal force minus the weight of the car will just equal 0. In the horizontal direction, we have the static friction force, and that is the force responsible for the car to remain in a circle. That equals the mass times the centripetal acceleration. Now, we can also solve for the vertical component of the force, that normal force equals mass times g. Then, solving for the horizontal force component, we can substitute the static friction for mu s, which is the coefficient of static friction, times the normal force. And that equals mass times, remember the centripetal acceleration equation we have been using? Let's just plug it in here as well. So it's mass times the speed squared over the radius. Let's solve for the normal force. We know that mass is 1200 kilograms times 9.8 meters per second squared. That equals to 11,760 newtons. Now that we have all of our variables except for the speed, we can just solve for speed by rearranging the equation and solving for speed. So speed equals to the square root of mu s times normal force times the radius over the mass. And that is all equal to 15.65 meters per second. That is how fast the car can go without sliding off the road. So I hope you liked this video. Do not forget to subscribe if you want to see more videos like this. And thank you so much for watching.